Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 16, Methods for Selecting a Random Sample. Classwork. In this lesson, you will obtain random numbers to select a random sample. You will also design a plan for selecting a random sample to answer a statistical question about a population. So here's example 1, sampling children's books. What is the longest book you have ever read? The Hobbit has 95,022 words, and The Cat in the Hat has 830 words. Popular books vary in the number of words they have, not just the number of different words, but the total number of words. The table below shows the total number of words in some of those books. The histogram displays the total number of words in 150 best-selling children's books with fewer than 100,000 words. So here is a list of books and the number of words in those books. So if I look, Green Eggs and Ham is at the bottom of the list at 702 words. The Cat in the Hat has 830. So Dr. Seuss didn't use a lot of words in his books because they're for young children. But then as we get older, the amount of words increases. So here's The Hobbit, 95,022 words. That is the largest in this set. But there are others that are up there as well, with Harry Potter and the Chamber of Secrets, 84,799 words. And The Secret Garden has 80,398 words. So many, many books with large numbers as well as smaller numbers. So this is just looking at a list of a few that had fewer than 100,000 words. Now on the next page, there's a histogram with total number of words for 150 best-selling children's books. So this list back here only had how many books? 27? 9 times 3? There's 27 listed here, but the total list has 150, and they created a histogram here of the number of words. So there are the majority of them have fewer than 5,000 words, and then fewer than 10,000, there's a frequency of 45 books. So we're going to answer some questions of this data, on this data. So exercise 1 and 2 are just that, they're exercises. So pause the video, see if you can do them, and then come back and see how you did. Okay, so these answers are going to vary because it says from the table choose 2 books which you are familiar with. So you might be familiar with books that I haven't read, and I may be familiar with books that you haven't read. So I'm going to go back and I'm going to look to see which ones I am familiar with. And let me just erase this. Okay, so Black Beauty, that's about a horse. The Catcher in the Rye, so there's one I would check. The Adventures of Tom Sawyer, I know that one. The Secret Garden, no. Mouse and the Motorcycle, no. The Wind in the Willows, no. My Father's Dragon, no. Frog and Toad All Year, no. Book of Three, no. Charlie and the Chocolate Factory, I know that one. Willy Wonka. Old Yeller, yeah, I know that one. Cat in the Hat, Green Eggs and Ham. Little Bear, no. Red Badge of Courage. Anne Frank, The Diary of a Young Girl, that's more of a history thing, but it's well known. Midnight for Charlie Bone, never heard of that. The Lion, the Witch, and the Wardrobe, heard of it but didn't read it. The Hobbit, heard of it, didn't read it. Judy Moody was in a mood, okay, did not read about Judy's mood. Treasure Island I've heard of but haven't read. Magic Tree House and so on. Harry Potter, Junie B. Jones and the Stupid Smelly Bus. Sounds interesting. Maybe I'll read that after this video. White Mountains and Double Fudge. Okay, so let's just make this easy and let me just pick these 2. The Catcher in the Rye, 73,404 words. 73,000 is, so it would be in this histogram bar. And the other one was The Adventures of Tom Sawyer, 69,066 words. So that would also be in there. So the 2 I chose are in the same bar. Describe the locations and the data distribution shown in the histogram. Okay, so So here's what I would say. I read, and look what two books I chose, The Catcher in the Rye and The Adventures of Tom Sawyer. So I could say, I read The Catcher in the Rye, and it has 73,404 words. If this is our median here, it is above the median number of words, and it would probably be in the upper quartile. Or actually, it'd probably be, if this was a fox and whisker plot, it'd be in the inner quartile to the right of the median. Okay, the other book I read was The Adventures of Tom Sawyer, and it actually had 69,066 words, which would also be above the median, within the inner quartile to the right of the median. So it's in the third quartile, if you will. Okay, so there you have it. Number 2, put dots on the number line below that you think would represent a random sample of size 10 from the number of word distribution above. Random sample of size 10 from the number of words distribution above. So what they're saying is if I chose books randomly from this list, okay, where would those dots end up? So maybe I'd pick this one, Green Eggs and Ham, 702. So then I'd come back here and I'd put a dot down here somewhere. So I will just randomly number these. Green Eggs and Ham was 1, and then maybe this one over here, and then this one and this one. I'm not doing anything. I'm not even looking at names. I'm just bouncing around and picking 10. So there's my random choice. So Green Eggs and Ham had 702, so maybe that's way down here. 2 was 84,799, which would probably be somewhere around here. Number 3 was 35,900, or almost 36, which would probably be around here. Number 4 was 22,000, which would be down here. And number 5 was 46,000, so here's 50, so maybe about here. And number 6, 11,049, that would probably be a little more than halfway between 0 and 20. 7, 82,762. And I'm going to compare that to my other 80,000, which was 84. So this one would just be to the left of it. Number 8. Okay, dog got a little excited there. Sorry about that. 8, 59,635, which would go about here. 9 is 69,066, which would be about here. And then 10 is 38,860. So that would be probably around here. Okay, so this is kind of an even distribution, kind of spread out evenly compared to the histogram, which was skewed heavily both directions. Okay, so if we look at that, there's a lot of data way down low and a bunch way up high, and then there's just a little in between. There's actually some that had spaces. So here's our dot plot of that. Random sample from those books. Okay. Number 3, or example 2. The histogram indicates the differences in the number of words in the collection of 150 books. How many words are typical for a best-selling children's book? Answer this question. Answering this question would involve collecting data, and there would be variability in those data. This makes the question a statistical question. Think about the 150 books used to create the histogram on the previous page as a population. How would you go about collecting data to determine the typical number of words for the books in this population? Okay, here's a sample response. I would add up all of the words in the 150 books and divide by 150. This would be the mean or average number of words for the 150 books. As the data distribution is not symmetrical, I could also find the median of the 150 books, as it would be a good description of the typical number of words. And there's a note. Discuss with students that using data for all 150 books is very tedious. That's what the population would be. A population is when you're using all of the data given. Okay, so as a result, students may indicate that selecting a random sample of that population, 150 books, might be a good way to learn about the number of words in these children's books. How would you choose a random sample from the collection of 150 books discussed in this lesson? Here's a possible response. I would make 150 slips of paper that contained the names of the books. I would then put the slips of paper in a bag and select 10 or 15 books. The number of pages of the book selected would be my sample. Okay, very reasonable way to collect a sample. The data of the number of words in the 150 best-selling children's books are listed below. Select a random sample of the number of words for 10 books. Okay, so here is one way we could do this. I could use the calculator, so let me open it. Okay, so here's my calculator. So if I go to math, probability, and number 5 says random integer. So if I go 5, and I want to choose values between 1 and 150, so I do 1, comma, 150, then every time I hit enter, it is going to give me a random value between 1 and 50. So when I hit enter, I got a 142. So then I'd come down, and this is 141. Here is 142. So I chose number 142. Okay, so that's how I would do this. Select a random sample of number of words for 10 books. So there's 1. Then I'd hit enter again, and I got 137. So here's 131, 2, 3, 4, 5, 6, 7. This is 137 right here. Okay, number 3, 23. Here's 21, 22, 23 is right here. Hit enter again, 78. Here's 71, 2, 3, 4, 5, 6, 7. Here is 78. Looks like a Dr. Seuss book. Hit enter again, 61. 61 is this book right here. So there's 5, and I keep going. Hit enter, 111 is this book here. Hit enter again, 7. 10, 9, 8, this one is 7. Hit enter, 51. That is this one right here. Go away. Hit enter, 150. That is actually the last book in the list. So now we have 3, 4, 5, 6, 7, 8, 9. I got to do this one more time. Enter, 31. So here's 31. So there is my random sample of the number of words for 10 books. So that's how I did it. Exercise 3 says, follow my instructions to generate a set of 10 random numbers. Find the total number of words corresponding to each book identified by your random numbers. So I just did that. So number 3 is done. I showed you that I use my calculator. Let me go through that again. If you have a Texas Instruments TI-83 or 84 calculator, you turn it on, you select math, and then you want probability. To get over there, you just have to arrow left once, and it goes over to probability. And number 5 is rand_int, which means random integer. And I'm going to pick, I could either pick 5 or do this and hit enter. And then tell it our parameters from 1, comma, 150. And then close the parentheses. So if you hit enter, it gives you a random number. So I just hit enter 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that was a new group of random integers. But I've already done this. This is my list of 10. So we're going to use that data for this video. So now that I've explained that and found the total number of correspondings, identify your random numbers. So I'm going to put them in order now, from least to greatest. So 830 is the smallest, then 860. Here's 7,000. That looks like the third one. And then we have 75,000. two that are 75,000. Interesting. 4 and 5. And then one that's a little more than 75,000 and 10. That would be 6. No, it wouldn't. 1, 2, 3. 58 would be 4. 75 would be 5 and 6. And 75,010 would be 7. 8 would be 80,398. 9 would be the 92,000. And 10 would be the 97,000. So now I'm going to write those down in order. So 830, 860, 7,682. $7,682. Let's not use a comma because I'm using commas between words. 7,682. And after that, wrong way. 4. 58,424. 58,424. Then the next ones were 75,000. And there were two of them. And then a 75,010. I remember that one. 3, 4, 5, 6, 7. So there's only 3 left. So that's 8, 9, and 10. So 8 is 80,398. Don't use commas in the numbers because we're using commas to separate. 8398. Oops, wrong way again. 9 is 92,409. And finally, the longest book from our list. 10 is 97,002. Okay, now it says choose 2 more different random samples of size 10 from the data and make a dot plot for each of the 3 samples. Okay, I'm not going to take the time to do this. I will do the one that I just did. You get the idea of how to do it. Just repeating it 2 more times is not anything that's going to be gained from that. So I'm just going to name this sample 1. And then I draw a line. Actually, let's do a neat one. Oh, come on now. Sample 1. Okay, so draw a segment. And then number that from, and then if I did this again, how about I just do this? Sample 2 and sample 3. Maybe I will do all of these. Okay, so here are our 3 number lines. They just lack numbers. So here would be 0. And then I could do it in increments of 10,000. So I'll write the word thousands down here. So I don't have to write all these zeros. So this is 10,000, 20,000, 30,000, and so on. And look at the data to see how high we need to go. The longest book looks like it's, well, it's under 100,000, so I have to go at least up to that. So let's just do that. 70, 80, 90, and 100. Now these should probably be more evenly spaced out, but you understand what's going on here. So 830 is less than 1,000, so that'd be way down here. And maybe I would move that up just above the line a little like that. All right, 860, right next to it. 7,000 would be over near the 10 more. 58,000 would be close to 60,000, which would be over here. Then 75,000, there were two exact, so I'm going to put one over the other. And then 75,010 is just a smidgen bigger, so I'll just put it to the right here. And let's see, 80,398 is just above the 80, so right about here. 92 would be about here, and 97 over here. So there is my sample from my first. Okay, so now let's take a look. If your teacher randomly chooses 10 books from your summer vacation reading list, would you be likely to get many books with a lot of words? Explain your thinking using statistical terms. So let me do this sample 3 more times, and I'll just use the calculator and not write them down. So I'm going to turn the calculator on. I'm going to do random integers. So let's start here right now. There's 147. Oh, I got to go back to my list. I'll just do this one more time. So I chose 147, which is 140, 150, 49, 48, 47 is right here. Hit enter. 42 is right here. Hit enter. 42 again, so don't count the same book twice. 19, which is right here. So there's 3. And hit enter. 8 is right here. Hit enter. 109 is right here. And hit enter. Oops. Enter. 2 is 1, 2 right here. Hit enter. 64. 1, 2, 3, 64 is this one. 3 more. Enter. 47. 50, 49, 48, 47. Enter. 141, 2, 3, 4, 5, 6 is right here. Enter. 5. Right here. And there's my 10. Okay. Okay, here's my screen capture of sample 2. So I'll do that one in red. 82,762 would be about here. 88,234 is down below 10, which would be over here. 75,338, halfway between 70 and 80. 81,451 would just be about right here. 1149 would be around here. Oops, move that up to this one. 81,388 would be around here. 87 would be closer to 90. 9,249, just under 10. 47,192, just before 50. And 89,239 would be just shy of 90 right there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there is my dot plot for sample 2. Okay, and then we would do that again a third time, but I'm not going to. And then it says, if I randomly chose, or if your teacher randomly chooses 10 books from your summer vacation, would you likely be getting many books with a lot of words? Explain your thinking using a statistical. Okay, obviously answers would vary, so here's a sample response. From my samples, it looks like I probably would get at least one book that had over 90,000 words. Because the maximum in each of the samples approached or exceeded 90,000 words. The 3 samples vary a lot, probably because the sample size is only 10. The median number of words for the 3 samples were these values respectively. So it seems like at least half of the books would contain about 50,000 words or more. That'd be based on someone's data where they had these values. So you'd want to mention those types of things in your sample. So you would want to say what you would estimate would be the number. So if I were looking at sample 1, I would say that the likelihood of choosing probably anywhere like 75 to 80,000 words would be probably be the one that would be chosen. At least one book with that value. I'd say the median number of words for the 3 samples were about, and in this case, I'd probably say the median was probably around 75,000 here. Or in this case here, 75,000. Same with this one, and maybe a little different on the third one, but I didn't do a third one, and so on. All right, you get the idea? Anyway, number 6. If you were to compare your samples to your classmates' samples, do you think your answer to exercise 5 would change? Why or why not? So again, answers would vary on this, and a sample response may say, the sample size is pretty small, so different samples might be different. I still think that I would have to read some books with a lot of words because of the shape of the population distribution. That would be a really good representation, talking about the shape of the distribution. Number 8. Okay, going back to this where I should be, exercises 7 through 9 says a statistical study of balance and grade. 7 is the following. Okay, so this should be up here. That's where I made the mistake. And now number 7. Is the following question a statistical question? Do 6th graders or 7th graders tend to have better balance? And yes, of course, this is a statistical question because the data collected would vary between 6th and 7th graders. 8. Berthio's class decided to measure balance by finding out how long people can stand on one foot. A. How would you rephrase the question from exercise 7 to create a statistical question using the definition of balance? Explain your reasoning. So go back and look at question 7, and it is, do 6th graders or 7th graders tend to have a better balance? Now we want to add that we're going to stand on one foot. Okay, and this question answers would vary. A sample response could be, what is the typical length of time that a 7th grader can balance on one foot? The data collected to answer this question will have some variability, 1 minute, 2 minutes, 2 minutes, 10 seconds, and so on. So it is also a statistical question. Part B says, what would the class think about to be consistent? What should the class think about to be consistent in how they collect the data if they actually have people stand on one foot and measure time? Okay, sample response would be, would it make a difference if students stood on their right feet or on their left? How high do they have to hold their feet off the ground? Can they do it barefoot or with shoes on? Would tennis shoes be better than shoes with higher heels? What can we use to measure the time? Now it says number 9, to work with your class to devise a plan to select a random sample of 6th graders and a random sample of 7th graders to measure their balance using Berthio's method. Then write a paragraph describing how you will collect data to determine whether there is a difference in how long 6th graders and 7th graders can stand on one foot. Your plan should answer the following questions. A. What is the population? How will samples be selected from this population? And why is it important that they be random samples? So here is a sample solution to that. Okay, so the populations will be all of 6th graders and all of the 7th graders in our school. So the population's all 6th and 7th graders. To get a random sample, we will find the number of 6th graders, say 62, and generate a list of 15 random numbers from the set 1 to 62, that is. And then when they generated it, they got 4, 17, 19, 25, and so on. Then we will go into one classroom, count off the students beginning with 1, and use student 4, 17, and 19. Then we will go into the next classroom and count off the students beginning where we left off in the first room, and so on. We will do the same for the 7th graders. This will give random samples because it offers every 6th and 7th grader the same chance of being selected, if using this plan with both grades. How would you conduct the activity? Okay, here's a sample response. Students will stand for as long as they can using whichever foot they choose in their stocking or bare feet with their eyes open. We will time them to the nearest second using stopwatches from our science class, or how about our cell phones? We will have students do the activity one at a time, out in the hall, so they cannot see each other. C. What sample statistics will you calculate, and how will you display and analyze the data? Okay, sample response could be the sample statistics will be the mean time in seconds standing on 1 foot for the 6th graders and 7th graders. We will make a dot plot of the times for the 6th graders and for the 7th graders using parallel number lines with the same scale. Part D, what would you accept as evidence that there actually is a difference in how long 6th graders can stand on 1 foot compared to 7th graders? Okay, we will compare the shape, center, and spread of the sample distributions of times for the 6th graders and do the same for the 7th graders. If the mean times are fairly close together and the spread's not that different, there is not really evidence to say one group of students has a better balance than the other. Okay, that is the end of lesson 16. Go do your problem set.